For millennia, humanity has gazed at the stars, wondering about our place in the vast, dark expanse. We built theories, pieced together models, and thought we had a pretty good handle on the story of the universe. We wrote a cosmic history book, filled with chapters on the Big Bang, the formation of galaxies, and the slow, majestic evolution of everything we see. But what if I told you that in just a few short years, a new eye in the sky has forced us to rip out entire pages and start rewriting that story from scratch? The James Webb Space Telescope, or JWST, isn't just another telescope, it's a time machine. Peering through cosmic dust with its infrared vision, it's looking back to the dawn of time, to the very first light that flickered into existence after the Big Bang. And what it's finding is not what we expected. Not at all. The universe, it turns out, is far more strange, more complex, and more magnificent than our boldest theories ever predicted. One of the biggest bombshells has to do with the very first galaxies. For decades, our models, like the Lambda CDM model, which is the standard model of Big Bang cosmology, painted a very specific picture. They told us that the first galaxies should have been small, clumpy, and a bit disorganized. Think of them as cosmic toddlers, slowly learning to walk, gradually merging and growing over hundreds of millions of years into the grand, spiral galaxies we see today, like our own Milky Way. It was a neat, orderly progression. But JWST looked back into that cosmic nursery and found giants. It discovered massive, well-formed, and surprisingly mature galaxies that existed just 500 to 700 million years after the Big Bang. That's like finding a fully grown adult in a room full of newborns. These galaxies are shockingly bright and packed with stars, some appearing even more massive than our Milky Way is today. Scientists are calling them universe breakers, because their existence flatly contradicts our established timelines. How did they get so big, so fast? Our theories of galaxy formation simply don't have enough time built in for this to happen. It's like trying to build a skyscraper in a week. The materials, the process, the timeline, it just doesn't add up. This single discovery forces us to fundamentally rethink how the universe jump-started itself. Did stars form much more efficiently in the early universe? Was there some unknown accelerator pedal on cosmic growth? We just don't know. And that's what makes this so incredibly exciting. It's not just the size of these early galaxies that's causing a stir, it's their shape. We expected to see irregular blobs. Instead, JWST is revealing early galaxies with distinct structures, including disks. A galactic disk, like the one our solar system resides in, is a sign of a stable, rotating system. We thought these took billions of years to form. Yet, JWST found a galaxy called Sears 212, a barred spiral galaxy much like our own Milky Way, existing when the universe was just a toddler, about 2 billion years old. Finding such a well-ordered structure so early on challenges our understanding of galactic dynamics and evolution. The universe, it seems, wasn't chaotic for as long as we thought. It got organized, and it got organized fast. And then there's the mystery of the stars themselves. We've long theorized about the very first generation of stars, known as population 3 stars. These were the true pioneers of the cosmos, forged from the pure hydrogen and helium left over from the Big Bang. They were predicted to be colossal, hundreds of times more massive than our sun, burning incredibly hot and living short, violent lives before exploding as supernovas that seeded the universe with the first heavy elements. These elements, which astronomers call metals, are the building blocks for everything else: planets, life, even us. We are literally made of stardust. For decades, finding a population 3 star has been a holy grail of astronomy. But despite their predicted brightness, they've remained elusive. JWST was built to find them. And while it hasn't directly imaged one yet, it's finding tantalizing clues. It has observed galaxies so ancient and so chemically simple that they seem to be powered almost exclusively by these primordial giants. In one incredible discovery, JWST studied a galaxy called GNZ11. This is one of the most distant and earliest galaxies ever observed. Within it, scientists found evidence of either extremely massive stars or even a direct collapse black hole. More recently, in a cluster called Pandora's cluster, Astronomers think they may have found a star group rich in these primordial stars. By analyzing the light from these ancient systems, we are essentially performing cosmic archaeology, piecing together the chemical evolution of the universe from the ground up. We are on the precipice of witnessing the moment the universe first switched on the lights. But perhaps the most mind-bending discoveries are happening closer to home, within our own galaxy and beyond. JWST is revolutionizing our understanding of star and planet formation. It has peered into the dense, dusty clouds of stellar nurseries like the Pillars of Creation and the Carina Nebula, revealing newborn stars that were previously hidden. We can now see the protoplanetary disks around these young stars in breathtaking detail. These are the swirling disks of gas and dust where planets are born. JWST isn't just seeing these disks, it's analyzing their chemistry. By studying the light that passes through their atmospheres, the telescope can detect the presence of specific molecules. And it's finding water, carbon dioxide, methane, and other complex organic molecules, the very ingredients for life as we know it, in the exact places where rocky, Earth-like planets are likely forming. This doesn't mean there's life there, but it does mean the raw materials for life are common throughout the galaxy. It suggests that the recipe that created Earth might not be so special after all. Speaking of other worlds, JWST has turned its powerful gaze to exoplanets, planets orbiting other stars. For the first time, we are not just detecting these planets, we are characterizing their atmospheres. Take the hot gas giant WSP-96b, for example. JWST delivered a detailed analysis of its atmosphere, clearly detecting the chemical signature of water vapor, along with evidence of clouds and haze. This was a landmark moment, demonstrating a capability we could only dream of a decade ago. More recently, it studied the TRAPPIST-1 system, a star system just 40 light-years away, with 7 rocky Earth-sized planets, several of which are in the habitable zone. While initial observations of the innermost planet, TRAPPIST-1b, suggest it has no significant atmosphere, the investigation is just beginning. As JWST works its way through the other planets in that system, each observation holds the potential to be one of the most significant in human history. Are we on the verge of finding a world with an atmosphere that could support life? The answer is waiting in the data. Even our understanding of the universe's ultimate fate is being questioned. The expansion of the universe is accelerating, driven by a mysterious force we call dark energy. Our measurements of this expansion rate, a value known as the Hubble constant, have a problem. Measurements of the early universe, from the cosmic microwave background, give us one number, while measurements of the local modern universe, using things like supernovae, give us another. This discrepancy is called the Hubble tension, and it's a major crisis in cosmology. JWST is uniquely positioned to help solve this. By refining our measurements of distances to faraway galaxies with unprecedented accuracy, it can help us build a more precise, cosmic distance ladder. This will either resolve the tension, showing one of our previous measurement methods was flawed, or it will confirm that the tension is real. And if it's real, it could mean our standard model of cosmology is incomplete. It could point to new physics, perhaps a new type of particle, or a dynamic form of dark energy that has changed over cosmic time. So, what does all this mean? It means we are living through a scientific revolution. The James Webb Space Telescope is not just collecting data, it's demolishing old certainties and forcing us to ask bigger, bolder questions. We thought we knew the story of the cosmos, but it turns out we'd only read the introduction. The universe is more dynamic, more surprising, and got a much faster start than we ever imagined. The galaxies grew up too fast. The cosmic recipe for life seems to be everywhere. The very fabric of space-time might be stretching in a way we don't understand. Every image JWST sends back is a new piece of a puzzle we didn't even know we were solving. It's humbling and exhilarating. We were not necessarily wrong about everything, but our picture was incomplete, like a charcoal sketch of a masterpiece that is only now being revealed in full, vibrant color. The James Webb Space Telescope hasn't just changed our view of the universe, it's changed the very questions we ask. And as it continues its journey, staring deep into cosmic history, one thing is certain. The universe will never look the same again. We are the first generation to witness this new cosmos, and the story is just beginning. Thank you so much for joining me on this cosmic journey today. If your mind is as blown as mine, make sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments which JWST discovery fascinates you the most. Until next time, keep looking up. For millennia, humans have gazed at the night sky, wondering what lies beyond our tiny blue dot. We've told stories about the stars, charted their movements, and built bigger and better tools to peer into the darkness. But everything we thought we knew is being rewritten, all thanks to a revolutionary new eye on the cosmos, the James Webb Space Telescope. What this marvel of engineering is showing us isn't just beautiful. It's fundamentally changing our understanding of the universe, and some of its discoveries have left scientists completely stunned. So, what is the James Webb Space Telescope, or JWST for short? Think of it as the successor to the legendary Hubble Space Telescope, but on a whole new level. Its primary mirror is a magnificent honeycomb of 18 gold-coated segments, stretching over 21 feet across. This massive mirror, combined with its advanced infrared instruments, allows it to see the universe in a way we never could before. While Hubble primarily sees invisible light, the same light our eyes see, Webb is designed to see in infrared. Why is infrared so important? Well, the universe is expanding. As light from the most distant galaxies travels across billions of years to reach us, it gets stretched out, shifting from visible light into the infrared spectrum. This is called redshift. Webb's infrared vision allows it to cut through this cosmic stretch and see the very first stars and galaxies that formed shortly after the Big Bang, over 13.5 billion years ago. It's not just a telescope, it's a time machine. Webb is literally allowing us to see the cosmic dawn, and what it's found there is shaking the very foundations of cosmology. One of the most shocking discoveries came when Webb pointed its golden eye towards what was thought to be empty space. It revealed a population of galaxies in the early universe that are far more massive and mature than our current models predicted. According to our best theories, early galaxies should have been small, clumpy, and chaotic. But Webb found several universe breakers, massive, well-formed galaxies that simply shouldn't exist so early in cosmic history. It's like finding a fully grown oak tree in a tray of freshly sprouted seeds. Scientists are now scrambling to figure out how these galaxies grew so big, so fast. Does this mean our understanding of galaxy formation is wrong? Or could it hint at new physics we haven't even dreamed of? But Webb isn't just looking back in time. It is also peering through cosmic clouds of dust and gas that are opaque to telescopes like Hubble. These are stellar nurseries, the birthplaces of stars and planets. With its infrared sight, Webb pierces through the veil, revealing the dramatic and beautiful process of star formation in breathtaking detail. We can now see protostars, baby stars, still wrapped in their dusty cocoons, and the powerful jets of material they shoot out into space. One of its most famous images, the cosmic cliffs in the Carina Nebula, looks like a fantastical mountain range, but it's actually the edge of a giant gaseous cavity carved out by intense radiation from young, hot stars. We are witnessing the creation of solar systems in real time. And speaking of solar systems, Webb is a game-changer in the search for life beyond Earth. It's giving us an unprecedented look at exoplanets, planets orbiting other stars. One of its key abilities is analyzing the atmospheres of these distant worlds. As an exoplanet passes in front of its star, Webb can capture the starlight that filters through the planet's atmosphere. By breaking this light down into a spectrum, scientists can identify the chemical elements and molecules present, like water vapor, methane, and carbon dioxide. These are potential biosignatures, tantalizing clues that a planet might be able to support life. Recently, Webb made a groundbreaking discovery on an exoplanet called K2-18b, a Hyson world which is potentially a water-covered planet with a hydrogen-rich atmosphere. Webb detected not only methane and carbon dioxide, but also a possible trace of a molecule called dimethyl sulfide. On Earth, this molecule is produced almost exclusively by life, specifically phytoplankton in our oceans. Now, this isn't definitive proof of aliens, and scientists are being very cautious, but it is an incredibly exciting lead. It's one of the most promising hints we've ever had in the search for extraterrestrial biology. The fact that we can even detect such a molecule from hundreds of light years away is a testament to Webb's incredible power. The telescope has also given us stunning new views of planets right here in our own solar system. Its images of Jupiter are almost otherworldly, showing the planet's auroras glowing at its poles, faint rings, and tiny moons all in one frame. It has captured the clearest view of Neptune's rings in over 30 years and provided detailed insights into the atmosphere of Saturn's moon, Titan. It's like seeing our cosmic neighbors with brand new eyes, revealing details that were previously hidden. But perhaps the most profound thing Webb has given us is a new sense of perspective. When you look at images like Webb's first deep field, you're not just seeing stars. Almost every single point of light in that image is an entire galaxy, each containing billions of stars, and potentially billions of planets. Some of the light in that image has been traveling for over 13 billion years. You are looking at the deepest, sharpest infrared view of the universe ever taken. It's a humbling and awe-inspiring sight that connects us to the vastness of time and space. The discoveries we've talked about today are just the beginning. The James Webb Space Telescope is slated to operate for a decade or more, and every day it sends back new data that has the potential to rewrite our textbooks. It's forcing us to ask new questions and rethink old answers. Are we alone in the universe? How did the first stars ignite? What is the ultimate fate of the cosmos? The James Webb Space Telescope isn't just a scientific instrument. It's a symbol of human curiosity, ingenuity, and our relentless desire to explore. It's a testament to what we can achieve when we work together to reach for the stars. Every image it captures is not just data. It's a piece of art painted by the universe itself, revealing its deepest secrets and most beautiful mysteries. We are living in a golden age of astronomy, and thanks to Webb, the universe will never look the same again. Thank you so much for joining me on this cosmic journey today. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments what Webb discovery has amazed you the most. Until next time, keep looking up.